Okay.
Okay, welcome everybody. My name is Kabrda. You may know me as Python maintainer in Fedora. And today I'd like to tell you something about the feature or change that I proposed for Fedora 22, and that is Python 3 as a default. So let me start by a little motto that I did for this presentation. So what if I told you that there is something better than Python 3? Who likes that? Who thinks that that's not possible? Right, okay. I'm not talking to you. So, agenda. What are we going to talk about? We're going to talk about Python 3, obviously. So, at first I'll tell you what Python 3 is, actually. I'll tell you something about the differences, like some differences from Python 2. I'll tell you what's new in Python 3. We'll briefly go over how the code porting works. We'll actually talk about what this exactly means for Fedora, having Python 3 as the default Python. I'll tell you how you can help us out if you're interested in this feature. And I'd like to have at least 10 minutes for questions and answers and discussion. So let's get to it. So what is Python 3? This is a quote from Nick Koffler, one of Python core developers. And he says that Python 3 is the programming language the creators of Python 2 prefer to use, which characterizes as pretty nicely, I would say. Python 3 is also known as Python 3000 or Py3k. It was actually, Python 3.0 was released, I think, in 2009, if I'm not mistaken. So it's like 5 years old, or more than 5 years right now. It's not compatible with Python 2x, not fully compatible, but you can write code that runs on both if you want to do that. Another point in this slide is that it's more Pythonic. What I mean by that is that if you know Zen of Python, who knows Zen of Python? Right, so almost everyone. So for those who don't, it's like a set of, I wouldn't say rules, but set of like quotes or assertions that should be right about the programming language, so about Python programming language. So for example, like there should be only one obvious way to do it. And in this sense, for example, Python 3 is certainly more Pythonic because it removes some redundancies in the language and keeps only one meaningful way to do stuff. And also, as the upstream says it, Python 3 is the present and future of Python language. Right now, Python 2 is actually just in bug fix mode and security fixes mode, which means that it's not developed, as in it's not getting new features. Only Python 3 is getting new features, and Python 2 is will be supported until at least until 2020, I think, maybe extended, but it's not getting new features. It's just bug fixes, security fixes. Right. So I'd like to go through some differences between Python 2 and Python 3. I'm only going to talk about pure Python code. There are, of course, differences for C extensions too, but that would be like too long. So I'm just going to go with the Python code. So print is no longer a statement. So you can't actually write print space true. You have to use that with parentheses around it. However small this change might seem, it actually upsets the most people. Like everyone says, I want to have my print statement back. It's like, it's so convenient. You're not getting it, sorry. I'm quoting upstream here, that's not my code, it's from upstream. But actually, the good thing about it is that if you use the for future import print function, you actually get exactly the print function. I'll get to it in a moment, okay? You actually get precisely the same print function as is in Python 3. That is, this works in Python 2.6 and 2.7. There was a question?
I wanted to know how far back that point feature would work, and the answer
Right.
is not on rel.
Not on which rel? Not
on rel 5.
not on rel 5, right. That wouldn't work on rel 5 because that has Python 2.4.
Or rel 6.
Right. Rel 6 has Python 2.6. It works there.
Okay.
Yeah.
Just not 2.5.
So, yeah, it's good on rel 6, not on rel 5.
Rel 6 has 2.6, so it's marginally useful.
Yeah. So this is one of the redundancies that have been removed is the haskey method, for example, of dictionaries. So instead of dict.haskey, you use key in dict. I also think this is nicer. Who thinks it's nicer? Lost to you guys. And also all the methods that started with iter something, so iter items, iter keys, iter values, were replaced with just dict dot items, values, keys. So, comment?
This is not specific to string.
It's not specific. It's been backported to 2.6 and 2.7. I think it's not in 2.5.
No, it is in 2.7.
Yeah, it is
a long time.
Yeah.
The first one.
Okay.
The first one goes for a long time.
Sorry about that, but the fact is that you can't use iter something in Python 3, which is like a redundancy that has been removed, right?
Although it's more than just a redundancy, it's a change of behavior.
Right, and also, yeah, I wanted to get to that, right? So the difference between these is that that the new methods, the items, keys, and values return what's called dictionary views, so the previous methods in Python 2.7, they actually returned lists. The new methods, they return iterators. So this is like for memory efficiency.
The iter methods didn't return lists. The iter,
Of course.
whatever methods return generator.
Okay, sorry.
That's the point. That's what
Sorry.
you say.
He said the old methods, which is like
The old, just dict what?
Oh, I get it.
Yeah, the old dict.items, for example, returned lists, while the new dict.items return iterators. And the old dict.iterItems returned iterators.
Yeah.
Sorry if I didn't make that clear.
I think they're actually views, which are and iterators.
Yeah, they are not literally, yeah, right. They are not literally iterators, they are dictionary views which can act as iterators, right? Okay. Are we clear on that? No more comment. Okay, thanks. String and Unicode handling. This is actually common point of failure when converting or porting your Python 2 code to Python 3. So in Python 2 there was a base string type. There was actually a superclass of string and Unicode, or str and Unicode types in Python 2. In Python 3 there are different types for strings. Byte, which is actually just binary data. It's not like specifically a string type. It's just supposed to hold some sort of binary data, like for example encoded string, but it's encoded, right? And there is string type str, which in Python 3 holds Unicode decoded data, which is so actual string. And the Python upstream decided that these two don't share enough common functionality to have a supertype. So there's no base string or something like that in Python 3. There can actually be some sort of problems when you port Python 2 code to Python 3 because, for example, if you use subprocess.popen, it returns bytes in Python 3, which you have to decode if you want to use them as strings, and all sorts of differences, but these can be ported pretty good to Python 3 and still work on Python 2, so it's not that big of an issue, but it is an issue, usually. Also, in Python 2, there were basically two integer types, long and int. In Python 3, they have been unified as an int, and int can actually hold integer of pretty much any size. Any questions for that?
I was actually using base string a lot, so if you check if I'm returning either a Unicode or a string. But who would you propose to do that? Depends.
So, what you're asking is that if your method is returning in Python 2 string or Unicode, which in Python 3 would map to bytes or string, how can you check like a superclass of that? So, for example, if you use the Python 6 library, which is like a good tool for having Python 2 and 3 compatible code. This has 6 dot, I'm not sure if it's string types. Text types, which has both. So you can check like is instance your variable and 6 dot text types, and will tell you everything, right? Any other questions?
They also added a few things. They added byte array, which is a mutable byte type.
Right.
And sometimes when you are checking for base, would have checked for base string in Python 2, you want to include byte array when you're doing that check. And so
Right.
it depends on what you're doing. So
Right.
you have to think about it.
Yeah. Again, I can't really go through everything, because I only have so much time. So, yeah. Thank you. So some more differences: map, filter, and zip, return iterators. In Python 2, there were similar functions which started with E, so IMAP, iFilter, and izip, which were used if you want to return iterators. Now in Python 3, everything returns iterators by default, and there are no other versions of these functions. Again, if you want to convert this to list, you just explicitly call list parentheses map something, and you get a list. So you can use this even in Python 2, and it won't actually do you any harm because it will do nothing. So you can use list something and it works in both Python. And the same basically applies to range and xrange. In Python 2, range returned list and xrange returned iterator. In Python 3, there's only range and it returns an iterator. There's slightly changed syntax when catching exceptions. This works, the new syntax, except my exception sfoo, works. I'm not sure since when. It definitely works in Python 2.6. I'm not sure if it works.
It's only 2.6.
Yeah, it's only 2.6 off, yeah. So again, when you're using like Python 2.6 or Rel 6 for that matter, you can just use this new syntax and everything works as it used to. So the old syntax is removed in Python 3. Imports. So I could probably talk a lot about imports, but the most important fact to get is that import foo is always absolute. What that means is that in Python 2, if you had foo module in the same package that used import foo, then it would import the module from that package. If you use this in Python 3, it will only try to import a package that is somewhere in your Python class and is named foo. So this will do something different in Python 3. The way to do it is use from.import foo or something like that. So absolute versus relative imports. Yeah, question?
Do you know if the relative imports check the current directory of the module that is importing that module, or is it like, does it prefix it with the package name?
I'm not sure I understand the question.
Well, in Anaconda, we use those updates images, and they contain the PyAnaconda package, Python package, and the module in it. So they are like overrides for our code. But this relative import, I think what happens is that it always imports the module that is in the same directory as the one that is imported. Like, it ignores the Python path or something like that.
But, like it doesn't, so you're talking about Python 2, right?
Yeah.
So it doesn't like ignore Python paths, it first tries to import module foo from the current package, and if it's not there, it tries to import that from Python path.
The not current package, but current directory of that module. That is the problem.
Right. Right.
So it doesn't work for us though.
What doesn't work for you?
Because we have the like overriding module.
We work on packages, inside packages. We need to have a package, not a module. Package is a directory where I have an underscore, init, dot.
Yeah.
And only inside the package it works. And we need to import the whole package.
Yeah, I know.
Just
Oh, maybe we can.
Maybe we can discuss it after
Yeah,
the
yeah.
presentation. Yeah, right. Okay, thanks. Any other questions for this? Okay. So, and there are more and more changes, some usually like smaller changes, like renamed or split libraries. Config parser, which was in Python 2 with capital C and P, is now config parser in lowercase. URL it was split. IO library was completely rewritten in C. There's no CNP function. You can't get representation with the backticks. And there are, as I've said, there are also changes in C extensions. Yes, please.
is there a replacement for CMP or what are you supposed to do?
You're actually supposed to compare as in lower than, bigger than, as in like, I don't know how these characters are actually
Like a
called.
lambda. or
Like,
something.
yeah, right. Does that answer the question?
That's-
Okay. Other questions? Okay. So, if you just look at the changes, it looks like that must be like really, really hard to port to Python 3, right? So, why would you actually do that? Why would you port to Python 3? So, now I'd like to go about some goodies that Python 3 has for you, and why, when we step from Python 3 to Python 3 and draw Python 2 compatibility, what we will be able to use. So, the first feature that is actually, I think, my favorite in Python 3 is keyword-only arguments. So, the way it works is that, for example, if you have this function foo, it has two arguments ab, then it has argument b equals false and explode equals false. Keyword arguments, right, with default value. Now, if you, this only works in Python 3, I mean, and the good thing about it is that you can't call it, as in the first example, foo 1.3, that will raise type error. Because you have to, if you want to provide a third argument, you have to explicitly say whether you're providing B or explode. This is really good because, for example, if you're using a library that has this function, and you want to use it in a Python 2 style, that means just providing 1, 2, 3, and the author of the library decides that he wants to swap arguments B and explode, then if you use foo 1, 2, 3, then 3 is true, right? So it will explode. In Python 3, it won't explode because you have to explicitly say which keyword argument you mean. So if you want to explode, you have to like shoot yourself in your leg. So it prevents accidental passing of more arguments than you wanted, or like errors when reordering arguments. And in some situation, it also helps you get rid of the double asterisk keyword arguments. Question?
I'm lost. What does exactly the star means?
Yeah.
It
So
should mean
this- sorry.
it should mean any number of arguments. So why the first example is
I,
wrong?
I didn't explain this in detail. So how this works is that if you provide just a star without like a variable name, just a star on its own, then that means that after this star, keyword arguments only come, right? Sorry, I didn't explain that clearly in the first time.
And that's new in Python 3, right?
That's new in Python 3. It's new at its syntax, so you can't actually use that if you want to keep Python 2 compatibility. Right, any more questions for this?
So there is no from future import keywords only argument stuff.
No from future import something like this. No, Python 3 exclusively.
Do you actually have the start of variable of the arguments? Like you can only specify
Yes.
what arguments?
Yes, you can have star like as a first argument, so all arguments are keyword only. Another one of my favorite features is change exceptions. So this is again edit syntax, something new in Python 3 and Python 3 only, no from future import something. And how this works is that, for example, you have a code that does some operating system stuff like unlink something, for example, and it's going to raise an exception. And you catch that exception, and you want to raise exception that is like specific to your application, like you have your own hierarchy of exceptions, right? So the nice thing in Python 3 is that you can specify raise some exception from E, where E is, for example, the OS error that you call it, and it will actually, if this exception like bubbles up and it's like printed for user, it actually contains all the tracebacks. So like you know specifically if you have a try except block that has like 3 OS functions and you want to know which one raised the error, you actually know this just by using that. So this is actually quite another cool feature that I think is just great in Python 3. Matrix multiplication. So the Python upstream has been noticing that Python is more and more used for scientific computing, you know, like libraries like SciPy or NumPy, these things, data analysis stuff. So they decided that in Python 3.5 they will implement matrix multiplication operator. That's the @ sign. The funny thing about this operator that it won't actually have any implementation for types in standard Python. It's only left there for other libraries like SciPy or NumPy to actually overload. So I like that. Don't you?
No.
No? Who said no? So then, okay. Why don't you like it?
Why have standard does nothing instead of like explain to me why is it cool? Where standard does nothing.
Yeah, so it's not like a standard library, it's a feature of language, not a standard library, right? And
You know,
so,
it's like we have multiplication, but in order to have multiplication, you need to import some SciPy. So it's not really like
yes, because standard library actually doesn't have any matrix stuff, right? So you could like maybe think of overloading it like for a list of lists, something like that. That would probably make sense,
Yes.
but there would be like very complex type checking that it's a list of lists that have this and that features, you know, and it would be all too. So Python developers just decided that they will leave this functionality just for extension libraries. I agree that it might not make sense to someone, right? Another question?
Actually, I think that if this is not there and you want to have matrix multiplication in the library, you would have to make it a method or function. And now you have an operator you can use. Or you can overload normal multiplication operator, but that might do something else. So basically, Python guys just gave give like new operator you can overload with anything you want.
Basically like that, yeah. So the way that it works is that you actually provide a method that has these double underscores on the side. I think it's called matmul, like as in matrix multiply. I'm not exactly sure about that, but it's like, so I think it's cool. Advanced unpacking. Again, another feature that is not available in Python 2 and probably will never be. So I guess these examples speak for themselves. So for example, the first one says that you want to get the first and last lines in a file, and the rest you want to just go in some variable that you don't really care about. So you can do it like this. Or you want to get like the last part of range or just a list or iterator, so you can just do it with advanced unpacking. I think this is a pretty cool feature too. Any questions on that?
Can I make it like def now or something, or I have to use a variable I will not use anymore?
You have to use variable that you will not use anymore. The way it is done, that they usually use like asterisk underscore, like just underscore for the variable. So it's like,
You have a trash variable.
yeah, it's basically trash.
Yeah,
Very cool. Subgenerators. Again, other useful feature. Who knows Python generators? Even in Python 2? Right? So generators are actually functions that yield values, and they like stop if you don't want them to yield more values, and when you ask them for more values, then they yield more values again. I hope you could understand that explanation.
Retain state.
Yes, they retain state. Okay, thanks. So now there's in Python 3 there is new syntax that allows you to have subgenerators. So you have your generator function, and in that generator function you yield values from a subgenerator. And this can actually be like completely arbitrary generator, or it can be an iterator, or it can be just a list, for example. Can be pretty useful in some cases. Questions? So, there are more, of course. In Python 3.4, a new async IO module was added. This is for doing synchronous IO in single thread. It's pretty complex module. It's complex. Let's not go over that. There's actually a very useful module called fold handler. It works in a way that if you import fold handler and call fold handler, I think it's .enable. I'm not sure about that. I think it's .enable. It works in a way that if Python segfolds, or if your extension module segfolds, this actually prints a Python traceback for the segfold. So you know exactly where you want to look for that segfold. This is extremely useful. I've already used that like 10 times or something while porting some extensions to Python 3. Finally, we have an enumeration type. Who likes that? Anyone? Okay. I like it. There are fine-grained OS error subclasses, can be useful. And there are no more what I call funny comparisons, like in Python 2 you can compare string ABC to an integer or pretty much anything to anything, and it will return something, and I think that's just not very cool. So, such features, right? So, how can we move to Python 3? So, if you decide to port to Python 3, you actually first need to decide whether you want to keep backwards compatibility. If yes, if you want your application or library to work both on Python 2 and Python 3, I advise that you decide to not go below Python 2.6, because otherwise it can get very, very hard. Question?
You can manage with 2.5, but it gets crazy in some places.
Yes, you can manage, but as you say, it gets crazy. So Python 2.6 is like reasonably backward forward compatible with Python 3.
HTML2 text works from 2.4 to 3.4.
That's good.
Yeah, it is interesting.
Yeah, I guess, yeah. And ideally port to 3.3 plus. I'm saying this because 3.3, Python 3.3 actually has reintroduced the Unicode literals, as in you can use U and string. It actually doesn't do anything because all strings are Unicode by default, but it's good for porting, purposes. So I advise going with 3.3. And of course, as usual, good test coverage is a must. There are some useful tools. 2.3. This is actually good if you want your application, if you want to port your application to run only on Python 3, because it basically scratches Python 2 compatibility in some ways. Or you can use Python Modernize. I have to admit, I just learned about this a week ago, which actually does something like 2.3, but it also keeps Python 2 compatibility. So it's also very useful. I've already talked about the Python fix library, which is 2.3 and Modernize. You run on your code and they give you diff or something, or rewrite the code if you tell them to. Python 6 is something that you import to take care of the runtime stuff, to handle that. And it's a pretty good library. I really recommend it for everyone. For every project that I port, I recommend use Python 6. It's a great library. And it's very small, so it doesn't slow down your application or something. And of course, it's always good to use other tools like PyPlace or PyPlace, which check your code for possible errors, and they know about Python 3, so they can tell you about some errors before you run the code actually. There are some resources. I'm not going to talk about them in detail. I hope after the conference the slides will be available at some location so that you can download the presentation and go through the resources yourself. I also included some resources on porting C extensions, which might be useful for some of you. And of course, you can always ask me, which is the email address right on the side. So, what does Python 3 as a default mean for Fedora actually? So there are two types of Python requiring code that I like to talk. It can be, sometimes the categories can be a bit foggy, but generally we have libraries and applications. I call libraries the things that people usually import, and applications that people don't import but users run. So libraries, for now, libraries, if it is at all possible, we should try to maintain Python 2 compatibility and just add Python 3-something subpackages. This is because we need to get porting easy for people. So we don't want to break the backwards compatibility. We want people to stay on Python 2 if they wish for some reason, and so on and so on. So these are libraries, and the second type, these are applications. So based on what users want, you can support both Python 2 and Python 3, or just use Python 3. If you know that no one imports code from your application, why bother maintaining Python 2 compatibility, right? Assuming you don't want to run on RHEL, which you probably won't. So some things it means and some things it doesn't mean, like having Python 3 as a default. It means that I hope you'll have Python 3 only on live CDs. We will prefer Python 3 for applications. So these are the things that no one imports, but have user bin Python 3 hashbank or something like that. And I also hope to somehow change the guidelines to do some stuff you'll see. Just wait for it. It doesn't mean that we will drop Python 2. it doesn't mean that we will force people to write downstream only patches. And this is a bit point of controversy. It doesn't mean that we will point user bin Python to Python 3. People keep coming to me and asking me, why don't you do that if you want to have Python 3 as a default? The reason why I want to do that is that there's an upstream recommendation that says distributions for the time being should point user bin Python to Python 2, even though it's not their default Python implementation. So whenever upstream recommendation changes, we will consider the downstream as well. Questions?
If you know, as you mentioned, Python 3 is the only Python on live CD. If you look at Ubuntu, they planned as the same, to have only Python 3. I think it was for Trusty, so 14.04. I didn't check how they went with it, but it was very hard rule. They rewrote basically every canonical tool to be Python 3.
Yes. I've recently been talking to Matthias Klose, who's one of the Debian/Ubuntu Python maintainers. And he told me, I didn't check myself, but he told me that they actually didn't achieve Python 3 on the live CDs because they have like 2 more libraries to port. And yes, there's a lot of, like myself in the past 2 months, I've sent patches to like 15 upstreams to port to Python 3. So there's a lot of work involved, and I'm working on it, and other people are working on it. But we want to go the way that upstream is first. So if we don't achieve it for Fedora 22, then 23 it is, I hope. Another question?
On the previous slide, you have said that we should support in applications both Python 2 and Python 3. And how it's performed? How should it be performed? Like via some Iterators or?
So you mean like C applications?
Yeah, no, Python application, but.
So, like as I said, then there are tools like Python 6, Python Modernize, and it's just doable. It just requires some effort to do so, right? I don't have the time to go into it, like into real detail how you should do this, but you can feel free to contact me or come to me after the presentation, and we can go over some specific details if you want, right?
Thank you.
Okay. So, how you can help out if you're interested? Who's interested? Cool. Non-zero amount. Great. Really? I didn't expect that.
Well, I don't know if I have time, but I
Great, thanks. The first link on this slide is the change proposal for Fedora 22. The second one is the page where and it is now up to date, I think, where we're tracking the progress. So you can just look there and see what needs porting, what's in progress, what has already been ported.
Or you can update it if you find something is not updated.
Yeah, or you can update it, or you can just put yourself there and say, hey, I'm working on this. Or you can just port pretty much anything else. We'll be happy for that as well. But this page basically tracks the dependencies from live CDs, and I think the packager tools also, like ProGMO package.
In a separate list.
Yeah, in a separate list. So live CDs in one list, and these other tools that we also like to have ported in another list. There's also been discussions about having Python 3 in Apple 7. For various reasons, this really needs a lot of consideration before doing this, because there are several ways how to achieve having Python 3 in Apple 7, and most of them will require lots of maintenance work. So I know that people are asking for this for good reason. I know that people need this, but please give us some time before we figure out how to do this in the best way. So eventually there will be Python 3 somehow in Apple 7. If you're interested right now, you can actually try software collections from softwarecollections.org. So there's Python 3 software collections that you can try. It works on Apple 7. And remember, upstream is first. So that's pretty much all from me. I actually did all this because of that cat. I like that cat. Okay, so that's all from me. Your questions? Or discussion? Question? Right?
You said that if you want to support Python 2, you should really just drop support at 2.6. But what if you can't? Are there tools and resources if you have to support, say, 2.4.3 from Run 5?
So the question is how you can actually support, for example, Python 2.4 and 3 something with the same code base, right? So Python 6 is really a help for that because I think it still supports like Python 2.4, so it can help you with lots of things. And there's always this possibility of having like different source files for Python 2 and Python 3. However, I don't like it. In some libraries, if you want to go as far as supporting Python 2.4, it's sometimes maybe necessary to do that, I think. But it's ugly. Yeah.
Or you have to do things like don't use exceptions or stuff like that.
Which is not optimal, right?
It is possible, but some things get very hard and some things get very ugly.
Yeah.
If you look at the python3porting.com website that Slavik had up earlier, he tells you how to do things for Python 2.6 and 2.7, and then if, like for exceptions, you have to do some really ugly stuff, and he tells you how to do that, and then he says, you know, if you
Don't do it.
avoid it. But it is possible. It just gets really, really ugly sometimes.
You can do 2.5, 2.3, and some libraries are made. You just don't like reading the code.
Yeah.
And it's not all of the code that you don't like reading, it's just certain pieces of the code like the exception handling.
Yep. Right. More questions, comments?
As far as the different Python 3 versions, I mean, we're up to, did you say 3.5 already?
3.5 is actually the next version that will be released. The current version is 3.4.
You suggested 3.3 as a good place to pitch that. Is that because most everywhere people that even have Python 3 have gotten to 3.3?
So the reason why I suggested is like really a minor reason, and that's, as I said, you can use the Unicode filter, like the explicit U before a string, which actually doesn't do anything in Python 3, but it's good for porting reasons, right? But I think that Python 3.0 and 3.1 are already not supported by upstream. I'm not sure about
Yes.
1, but 3.0 is not.
And
So
3 point, the only like Python 3 in the wild which is available is Ubuntu has, some old Ubuntu has 3.2.
yeah.
So
Yeah.
like supporting anything below 3.2 is just pure masochism, like enjoy it, but
You can do that, but like
somebody
almost
has
no
to
one
compile
that.
3.1 on his own from Tarbos. Like
You have to support all Python 2 versions because there are some crazy distributions like Red Hat Enterprise Linux that have these old
no.
versions.
I was
You don't have to
saying.
support all Python 3 versions because there is no Python 3 in Run,
Yeah.
right?
I was the one who was screaming on our Python maintainers that not having Python 3 is stupid, but let's not go there. But no, I was talking just about Python 3.0 and 3.1, which really you don't.
I think almost no distros have that, so you don't really have to bother. Okay, more questions, comments?
How about,
Oh, sorry?
how about cross-platform? Is Python 3 pretty ready available for folks on Windows, Mac, etc.?
Yes.
If you're writing a library or a client that, yeah, maybe.
Yeah, it's available like Ruins, something on Windows. They do precompiled binaries, so yeah, everything's ready.
Is it faster than Python 2?
Like,
You know it's not.
it's faster. It's, talking about Python 3.3, that's been the first version that's actually been like faster in some regards than Python 2.7 and slower in some other places. Python 3.4 keeps getting better, and Python 3.5 should actually be at least as good as Python 2.7 because the upstream is like in almost every regard, right? As it is right now, for Python 3.5, the upstream has decided to rewrite the startup sequence, which has been really slow in Python 3. So this is like common corner case like for simple scripts, because if you run a simple script that has like a long startup sequence, it's just slower, right? Because you just can't tell the differences in the actual code. It's just the startup sequence is slow. But it's scheduled to be rewritten, and as I said, already Python 3.3 is, for example, much faster in I/O operations. Like the I/O module has been completely rewritten in C, and it's much faster. Unless you use it on NFS, because it does a lot of syscalls, and if you do it via NFS, that can happen. But yeah, usually it's faster in I/O operations. And so some other things, and I admit that some other things are slower. It is the way it is. Yeah. Okay. Other questions?
Can you summarize the status of having Python 3 default in Fedora for everybody? How are we standing now?
So, how are we standing with Python 3 as a default right now? We're basically tracking, right now we're tracking Fedora Workstation Live CD and Fedora Cloud. I think it's called Base or called Manual, or how is it called? The Fedora Cloud is either in work or just two packages are not being worked on right now from Fedora Cloud. So this is quite good. I'm quite confident that we can do Fedora Cloud. Regarding Fedora Workstation, I think we still have like maybe 7 to 10 packages to convert. Some of them are really big and ugly, like Samba, which has like tens of thousands lines of C extension code for Python, which is not converted to Python 3. So this is going to be really ugly. I'm actually thinking like the other way to approach this is to cut this dependency from LiveCD, right? For now. I'm not sure if we can actually do that for Samba. I actually haven't checked why it is on LiveCD. But like one way or the other, right, I should end. So like if there are any other questions, please come to me after the presentation, right? Thank you.